I was hoping to maybe clear up some more of our confusion around vertical versus horizontal dilation. As you see here, I've got an absolute value parent graph, that's the red one, and then I've got the blue one, which is either a horizontal or a vertical dilation, depending on how you think about it, because it just so happens that the absolute value of 3x looks exactly the same as the absolute value of 3 times the absolute value of x. But that doesn't happen. Once you shift it or do another dilation or something to it, it doesn't work that way. But for this one, it does. So let's take a look at a point on here and see that when we talk about a vertical dilation, it stretches the y values and the x values stay the same. So for instance, if I pick the point 2, 2 on my parent graph, and I see that it goes to 2, 6, I can see that for f of x equals 3 absolute value x, it multiplies y values by 3. Anywhere you do that, it's going to do the same thing. You know, here's 1, 1, 1, 1. Where it moves up to in the new graph is 1, 3. So the y value got multiplied by 3. So that's what vertical dilations do, and I think they're a little more obvious, but I think that once you understand what horizontal dilations are doing, it'll make sense also. So with a horizontal dilation, we're taking a point from the parent graph and we're moving just the x value. So for instance, this point, let's find a nice point here. Let's find a nice point. So if I find this point 3, 3, where does 3, 3 end up on the new graph? Well, 3, 3 ends up at 1, 3, because with horizontal dilations, we're multiplying the x value. So the x value over here, 3, got multiplied by 1/3, and that's why it ends up at 1. That's why we have to deal with the reciprocals with horizontal dilations. So if I said f of x is equal to the absolute value of 3x, which looks the same as the original one I had, we have to multiply the x value by the reciprocal, the 1/3. Any point that you take on here, you know, here's the point 6, 6. I'm picking ones that are going to come out nice. 6, 6 ends up at 2, 6. So it's, again, the x value that changed on those things. 6 times 1/3 is equal to 2. And that's why horizontal dilations squeeze. If you're doing a 3x, that means that you're doing a shrink by a factor of 1/3. If I wanted to go the other way, if I wanted to have a stretch, it would be something that's wider. So for instance, it would be like 1/4 x would be multiply the x values by 4. So let's keep that in mind. If we do one last table for an absolute with a horizontal shrink and all that kind of stuff, if I have something like this, minus 4, let's make sure that people are on board with that. So once again, this is a quadratic because I got a little squared thing going on there, right? Or do I have the squared in the wrong place? I have the squared in the wrong place. I apologize. For this to be a horizontal dilation, it has to be affecting the x. So the -2 would have to get squared along with that thing if we were multiplying it all out. My apologies. It's late at night. So 2, 4, 2 squared is 4, and so forth. We know that this is the parent graph for quadratics. And with this thing, we're doing multiply the y values by 3 because it's a vertical dilation by 3. So 12, 3, 0, 3, 12. And then a horizontal dilation by a factor of -1/2. because this -2 in here, inside the whole mess that's happening, whether it's inside an absolute value bar or inside the whole thing that's being squared, that would be multiplying the x values by -1/2. So -1, -1/2, 0, 1/2, and 1, like so. I think that we're okay with the translations now. Most people are pretty good with this. Let's see, add 1 to the x values. So we're going to have 0, 1/2, 1, 1.5, and 2. And the y values, we subtract 4. So 8, -1, -4, -1, 8. And there you go. So this is a horizontal dilation by a factor of -2, or by the -2 means that's a horizontal dilation by a factor of -1/2, a vertical dilation by 3, and then the shifts. So I hope this helps understanding in terms of what's going on with horizontal versus vertical dilation in terms of the changing the x values or changing the y values, and why it is that we take the reciprocal of that the x multiplier to make it so that it works out the way it's supposed to work.